So I believe this is recording. Let's take a look at these three problems. They give us two functions, f and g, and they want us to determine if these are inverses of each other. So let's jump in and find the function composition, f composed with g and g composed with f, for each one of these. So for this first one, for this w, f composed with g, where g is the input of f. G is this linear function 3x plus 4. F is a ratio here where the denominator is always 3 and the numerator is the input minus 4. And for us, this input is 3x plus 4. So we can see in the numerator that the positive 4 and negative 4 cancel, and that 3 divided by 3 is 1. So it's very likely then that these are going to be inverses, but it is necessary for us to find the other composition. So here f is the input for g. F is this ratio, and g is this linear function. G always takes 3 times the input and then adds 4. So this time the input is this ratio, and 3 divided by 3 is 1, and the negative 4 and positive 4 cancel with each other. We get x. So we conclude that these two functions are inverses of each other, and you could rename g as f inverse, or you could rename f as g inverse, just to illustrate the relationship. So let's erase this and do this middle one here. It looks like it's an I. Well, this is so large. Oh, now it's too small. All right. So for this middle one, let's find f composed with g. This is when g is the input for f, and g is this reciprocal function here. G is looks like a 6. Well, our quality of our, hopefully you can read it on your paper. 6 over x is what it looks like to me. I'm sure you can read it. Your eyes are much better than mine. F is a ratio where the numerator is always 6, and the denominator has 2 terms, where the first term is the input and the second term is plus 7. So our input is 6 over x plus 7. So what do we have here? We have 6 over x plus 14. And I'm going to multiply this ratio by the number 1. But I'm going to write 1. I'm going to look at this denominator and see that it's an x. And I'm going to write x over x. So to multiply fractions is pretty easy. You just multiply straight across the numerator and straight across the denominator. So in the numerator, we have 6 times x. And in the denominator, we have a binomial here, and both terms are being multiplied by x by the distributive property. So when I take this x and I multiply it by the first term, the x divided by x cancels, and that product is just 6. When I multiply it times the second term, I get 14x. I can see this doesn't reduce to x, but I also see that those are all even numbers, so I can't resist reducing this ratio. Half of 6 is 3, half of 14 is 7. And remember, I can't cancel terms, so this doesn't reduce any further. And since this is not equal to x, I know that these are not inverses of each other. Unless I've made a silly mistake in the arithmetic or in the algebra in finding this f composed with g. So let's find g composed with f. This time f is the input for g, and f is this ratio, 6 over x plus 7. G, in the first term, take 6 divided by the input and then add 7. So this input itself is a ratio. So what I have in this first term here is this 6, and I can rewrite this fraction bar as division. And I can change that division to multiplication if I take the reciprocal of this divisor, if I flip this fraction. So what does that give us? This 6 that's in the front there can be thought of as 6 over 1. So when you multiply these together, this 6 divided by 6 just gives you 1. And that first term there, we get x plus 7. And then if we add another 7, we have x plus 14. That's not equal to x. And we know that these are not inverses. All right. That was I still have this last one to go. So I want to do the same thing. I want to find each of the compositions and determine whether they reduce to x or not. So f composed with g means that g is the input of f, and in this k here, g is this linear function 2x minus 10. What f does to the input, f always creates an addition problem where it takes half of the input and then adds 5. So our input is 2x minus 10. So when you distribute this, when you multiply both of the terms here, you have half of 2, which is just 1, and half of negative 10, so you have a minus 5 and a plus 5, and those cancel, and it looks like that these are going to be inverses. Now, to truly verify that, we have to make sure that g composed with f also reduces to x. So this time, f is the input of g. And f is this linear function, this 1/2 x plus 5. G is also a linear function. G will take, in the first term, 2 times the input and then subtract 10. So we have this input 1/2 x plus 5. So we distribute this 2 to both terms. That multiplication distributes over addition. 2 times this first term, 2 and 1/2 are reciprocals, so they multiply together to be 1. And 2 times 5 is 10, and then we have this minus 10. So this does reduce to x, and we make the conclusion that these are inverses of each other, in which case you could come back and rename either one of these functions. You could rename f and call it g inverse, or you could rename g and call it f inverse. Hope that helps, and I will talk to you later. Bye.